Hi friends, in the continuation of data science interview question answer series, we are moving to question difference between k-means clustering and DBScan clustering. K-means cluster formed are more or less spherical or convex in shapes and must have same features size. In DB-scan clustering, clusters formed are arbitrary in shapes and may not have same feature size. K-means clustering is sensitive to the number of clusters specified. DB-scan clustering number of cluster need not be specified. K-means clustering is more efficient for large data set. DB-scan clustering cannot efficiently handle high dimensional data set. K-means clustering does not work well with outlier and noisy dataset. DBScan clustering efficiently handle outliers and noisy dataset. K-means clustering in the domain of anomaly detection. This algorithm causes problem as anomalous points will be assigned to the same cluster as normal data points. DBScan algorithm, on the other hand, locate neighbors regions of high density that are separated from one another by region of low density. K-means clustering, it requires one parameter number of cluster. DBScan, it requires two parameter radius and minimum points. R determines a chosen radius such that if it includes enough points with it, it is dense area. M determines the minimum number of data points required in a neighborhood to be defined as a cluster. Varying density of the data points does not affect K-means clustering algorithm. DB-scan clustering does not work well for sparse data set or for data points with high density. Moving question. Difference between multilayer perceptron and linear regression. Multilayer perceptron or network of neurons that can be used in binary multiple class classification as well as regression problem. A linear regression model determines a linear relationship between the dependent and independent variable. The output function can be linear or continuous function. It need not be straight line in multilayer perceptron, but in linear regression, the output function is linear and can be represented in a straight line. An MLP has multiple layer of neurons with an activation function and threshold value. A linear regression model has no activation function or threshold value. An MLP usually has multiple input through its one or more input neurons. Linear regression, simple linear regression requires only a single input, the value of the independent variable, to predict the value of dependent variable. MLP are mostly used for supervised learning but has been used in unsupervised learning for clustering in rare example like Cohen self-organization map. Regression is supervised learning technique. Area of application of MLP include pattern recognition, autonomous vehicle driving, social media recommendation. Area of application of linear regression include prediction of housing price, prediction of sales for the business, prediction of crop yield with respect to rainfall. Moving to question, difference between parametric method and non-parametric method. Parametric methods used a fixed number of parameters to build a model. Non-parametric methods used the flexible number of parameters to build the model. Parametric analysis is to test group means. A non-parametric analysis is to test median. Parametric analysis, it is applicable only for variable. Non-parametric method, it is applicable for both variable and attribute. Parametric methods, it always consider a strong assumption about data. Non-parametric method, it generally fewer assumption about data. Parametric method require lesser data than non-parametric method. Non-parametric method requires much more data than parametric methods. Parametric method assume to be normal distribution. There is no assumption distribution in non-parametric method. Parametric data handles intervals data or ratio data, but non-parametric methods handle original data. Here, when we use parametric method, then the result of the outcome generated can be easily affected by outlier. When we use non-parametric method, then the result or output generated cannot be seriously affected by outlier. Moving question, difference between decision table and decision tree. Decision tables are tabular representation of condition and action. Decision tree are graphical representation of every possible outcome of decision. We can derive decision table from decision tree. We cannot derive decision tree from decision table. It helps to clarify the criteria. It helps to take into account the possible relevant outcome of decision. In decision table, we can include more than one or condition. In decision tree, we cannot include more than one or condition. It is used when there are a small number of properties. It is used when there are more number of properties. In decision table, it is used for simple logic only. Decision tree, it can be used for complex logics as well. Decision table, it is constructed for row and tables. Decision tree, it is constructed of branches and nodes. The goal of using decision table is generation of rules for structuring logic or basis of data entered in the table. A decision tree objective is to provide an effective means to visualize and understand a decision's available possibilities and large uh, range of possible outcomes. Please like and subscribe the channel. Thank you.